In this video, we are going to discuss February-March 2023 paper 5.2, which is probability and statistics 1. Okay, so question number 1. Each year, they give us the total number of hours, okay, of X, right? So, of sunshine in Kintu is recorded during the month of June. So, the results are shown in the table, right? So, the number of years here is 60 years in total. Okay, so first of all, they want us to draw a cumulative frequency graph to illustrate the data. Alright, so we need cumulative frequency graph. So for cumulative frequency graph, y-axis will be the cumulative frequency and the x-axis will be the upper class boundary. Therefore, before we start to draw or sketch the graph, we need to list out the upper class boundary first. So this is an upper class boundary or upper class limit, upper class boundary. And then we also want to have the cumulative frequency. So we are having cumulative frequency here. Okay, so first, we don't have any data that's smaller or equals to 30. Therefore, our very first class, upper class boundary, I will start with 30 first. Okay, so smaller than 30, there's no frequency, which is smaller than this value. So the frequency is 0. Okay, so this is to ensure that my cumulative frequency graph later, right, you will start from the 0.00, okay, or not to say the 0.00, but you will start from the value y equals to 0. Okay, so for the next class, the next upper class boundary will be this one, which is smaller than 60, and the number of years will be the frequency, which is a 4. So I will write like this, smaller 60, and I'm having the cumulative frequency 4. Next upper class boundary will be 90, so I will put it as 90. To get the next cumulative frequency, you need to take 4 plus 8. You need to add or sum these two frequencies together to get the cumulative frequency, and we get a 12. Okay, so again, next upper class boundary will be 110, and the next cumulative frequency will be 12 plus 14, or you can take 4 plus 8 plus 14, and from here you'll get 26. So we'll repeat the process until the last class. Okay, so 440, then plus 25, I have 51. Next class will be 180, upper class boundary, then 58. And the last one will be smaller equals to 240, then I put a 60 here. So please take note that for the last one, for the last upper class boundary, I'm using the equal sign because of the sign given in the table. Okay, with the equal sign, therefore I put it as equal sign as well. But when you plot, we are looking at all the value. Alright, so once we have all the upper class boundary and also the cumulative frequency, then we can start sketching the graph. Okay, so to sketch the graph, we have okay, so the smallest value for the x-axis will be the 30, and the largest value should be 240. Then for y, the smallest value is 0, the largest value is 60. So from here, we should try to form, okay, or plot the suitable scale or ratio for the x and also the y-axis. So I will make the graph smaller, then I will start to form the graph. Okay, so maybe for the x-axis, I will want to start the 0 from here. Then for every 2 cm, I will put it as 50 units. I want to have my largest value is until 250 so that it covers the 240 in the upper class boundary. So the label for this one is the total number of hours. Which is the x. Okay, then for the y-axis, the highest value is 60. For the cumulative frequency, so we can start, maybe we can plot it out, right? So let's say this is 10, 20, then 30, and so on. Okay, so I might want to slightly extend it a little bit more. And let's say this is 60. Okay, and then don't forget the label for the y-axis, it should be the cumulative frequency. Okay, so once I done set up already, then I can start plotting the points. Okay, so for the first point, it is at 30 with cumulative frequency 0. So we will try to see where is 30, cumulative frequency 0. So to me, I think it is somewhere here. Then the second value will be 60 and also 4, right? 60 and 4. So we measure roughly where is the 60 and then we try to plot the 4. Okay, so we'll continue the process for every single point that we try to find out just now. Next value will be 90 at 12. Okay, 110 at 26. 140 at 51. 140 at 51. So maybe for me, my value is here 51, somewhere here, right? Okay. Then after that is 180, 58. And next one, 240 at 60. So after we plot all the point here, we try to connect them by using a smooth curve. Okay, so this is how our cumulative frequency graph look like now, right? So don't forget to label, okay, all the x and also the y axis, okay, by using the suitable scale. Okay, so this is how we sketch it. And now let us proceed to question number B. Okay, so for question number B, they want us to use the graph to estimate the 70th percentile of the data. So again, when we are looking for percentile, first of all, I need to know in which location I need to start reading the graph. Alright, so we are referring to the total frequency, which is 60 lah. So we are having 60 years in total, and the 70th percentile of 60 years will be 70 divided by 100 multiplied with 60. So from here I get the value 42. So that means I need to read the value from the cumulative frequency scale, cumulative frequency axis from the value 42. So again, if I look at my diagram here, where is 42? So 42 should be somewhere here. Okay, so this is a value 42. We try to draw a horizontal line so that it touch the axis, and then we will reflect it down. So it touch the graph that we sketch, and then we reflect it down to the x-axis to read the value. Okay, so if you try to read the value here, what we have, we should have 110, then 120, okay, then 130, right? So it is between 120 and 125. So maybe for me, I'll write the value as 123 or 122.5 also can, right? So maybe I write as 123. Okay, so while we are reading the value from the graph that we sketch, so we have to ensure that the graph that we draw, right, is actually as smooth as possible, and also with the correct point plotted, right? Okay, so from here I get the value 123. Therefore, I can write it in my solution here, where the 70th percentile is equals to 123. Alright, so this is how we read the value from the cumulative frequency curve. So next one, they want us to calculate and estimate for the mean number of hours of sunshine in Kintu during the June over the last 60 years. Okay, so now we want to calculate the mean. Alright, so before we want to calculate the mean, basically the general formula will be the summation of fx divided by the summation of f. X will be the midpoint of the data for every single class, and then the f will be the frequency. So in our case here, the f frequency is the number of years, and then the x is the midpoint of the class. So we need to refer back to the table again, and we try to find out the midpoint. Okay, so just to show you some example here, if let's say I'm having the first class, to get the x, the midpoint, basically you take 30 plus 60 divided by 2. So from there you get 45. This is the midpoint. And then for the second class, you take 60 plus 90 and divided by 2. And from here you get 75 and so on. Alright, so after I find out the midpoint for all the classes, then I've tried to pair it with the number of years, which is a frequency. I will continue with the calculation for mean here. Right? So if I write out properly for the mean, in the solution, please make sure that you show the value of the midpoint. Okay, so fx means that first frequency is a 4, first midpoint is 45, right? So you take 4 multiply with 45, then plus 8 multiply with the second class midpoint, which is 75, and then 14 with 100, the midpoint for the third class, and so on. Then divided it by the total frequency. So the total frequency that we have in this case is 60. Simplify all the value on the numerator. I got 6845 divided by 60, and you can simplify it into 1369 over 12, or you can change it become 3 significant figure answer, which is 114. Okay, so this is how we calculate the mean from the data given. So please take note that in your solution, make sure you write out the midpoint for every single class in your calculation. So like when I write out the step like this, okay, although it's a bit long, but in the solution here, I actually show all the midpoint for every single class. And this will actually contribute marks, maybe in the method mark, okay, for this question. Alright, so this is how we answer question number. Okay, so question number 2. Alicia has 4 coins, and then one of these coins is biased. One of them are biased, and then the probability of obtaining a head is 0.6. The other 3 coins are fair, so she throws all the 4 coins at the same time. The random variable x, the definition for x will be the number of heads obtained. So first of all, they want us to show that the probability of obtaining exactly 1 head is 0.225. Okay, so now let us start the calculation here. Okay, for this question, they are interested in the probability of having 1 head when she throws all the 4 coins. Okay, and then out of the 4 coins, right, we are having 1 biased coin. So we should try to consider the outcome. When do we have 1 head when we throw the 4 coins, alright? So very likely we might have the head appear at the bias coin. So the B here means bias. So that means HB means in this case I represent it by using this letter where the bias coin is showing a head. Okay, then the other 3 normal coin will be T, will be the tail. So for this case, you can see that out of the 4 coins, I have only 1 head obtained, and then this particular 1 head actually appear on the bias coin. Okay, so besides this, what else do I have? I might have also the case where the bias coin show a tail, and then the normal coin show a head. One of the normal coins show a head, then the other 2 normal coins show tail. Okay, so this is another result. So if you can see this result, basically you know that we have only 1 head, and the 1 head appear on the normal coin. And then since we are having 3 normal coins, right? So by right, we also can have something like this, DHT. The head shows on the second normal coin, and also we are having the third normal coin shows the head. So we are having three cases here, and the probability for these three cases should be the same. Therefore, to save the space, I just write it as times 3. Right, that means we need to consider HTT, THT, and also TTH in the normal coin. Alright, so after I list out all the possible outcome already, then I will start to calculate the probability for every single case here. So to get the head in the buyer's coin, I will get 0.6. Then tail in the buyer's coin will be, tail in the normal coin will be 0.5, and then 0.5, and then 0.5. So if you have a look in detail, right, this is basically for the buyer's coin with the head, and then all the remaining part will be the tail on the normal coin. So if you want to save space also, you can write as 0.6 and then multiply with 0.5 power 3. Then plus, same thing happened for the next outcome. We are having the tail on the buyer's coin, which is 0.4. Okay, and then for the head on the normal coin is 0.5, since it is fair, right? It's fair coin. So 0.5 and 0.5, and you can simplify, become 0.5 power 3, and then multiply with 3 lah. Like I already showed you just now why we need to multiply with 3. Okay, so from here, once you calculate out all the probability, okay, please try to add them together and simplify them. By right, you should have 9 over 40, or the answer that they want us to show, which is 0.225. Okay, so this is how we get the question part A, the answer part A. Okay, so we can proceed further to part B. For part B, they want us to complete the probability distribution table for the X. So for this case, right, the number of head when we throw the 4 coins can be 0 coin, can be 0 head, can be 1 head, 2, 3, and 4 heads maximum. Alright, so we are going to calculate the probability for obtaining 3 heads and also 2 heads. Okay, so maybe I will start from the easier one first, which is the 3 heads. To get the probability of getting 3 heads, the concept is very similar like what we tried in part 1 just now. Okay, so 3 heads means that I have 3 heads and 1 tail, right? Okay, so the possible outcome will be maybe for the buyer's coin, I get the tail, and then the remaining fair coin, I get all the heads. So this is the result where I'm getting 3 heads in the throw of the 4 coins. Okay, and for this question, for this outcome, I don't need to multiply with anything because H are head for the fair coin. They are all having the same outcome. So we don't need to consider the different cases. Then plus, okay, now how about if let's say for my buyer's coin, I had the head. If my buyer's coin, I had a head, that means for the normal coin or the fair coin, right, I should have only 2 heads among 3 of them. So for the normal coin or the fair coin, I have 2 heads with 1 tail. So if you have a look for this outcome, it is basically still 3 heads obtained. Just that one of the tail appear in the fair coin. So for this case, right, we also have more than one result where besides the third normal coin showing the tail, I can have also the second normal coin showing the tail, or maybe the first normal coin or fair coin showing the tail. Alright, so we are having 3 results here for 3 set of answer, right? For this kind of result, for this kind of outcome, therefore I have to multiply with 3 also. Alright, so these are the possible cases that we have 3 heads and 1 tail in throwing 4 coins. Okay, so after I list out everything, then I will start to put in the probability. What is the probability of getting a tail in the buyer's coin? It is 0.4. The probability of getting head in a fair coin should be 0.5, right? And then same thing happen for the remaining 2, so I'm having 0.5 power 3. Then plus, to get the head in the buyer's coin, it will be 0.6. No matter you want to get the head or tail in the fair coin, right, the probability is always 0.5 since it is in the fair coin. So I'm having 0.5 power 3. And then I need to multiply this result by 3. Okay, so if you try to have a look here, simplify the answer, basically I should have 11 over 40, or we are having 0.275. Okay, so we have done the case where x equals to 3, 3 heads. So for your information, right, before I forget, this is basically the answer for x equals to 3. 3 heads. Number x denotes the number of heads obtained. Alright, so 3 heads means that it is x equals to 3. So now we proceed to the case where I'm having 2 heads, where x equals to 2. Okay, so to get 2 heads, again, we try to list out all the possible results first. Okay, so first case maybe is for the buyer's coin, I get a head. So another head will only appear in one of the normal coin, right? And I have 2 tails for the normal coin. Okay, so for this case, we assume that this is fixed. Okay, we assume that this is fixed, where the buyer's coin definitely get a head. Okay, so we fix this, and then we just focus on these 3. For the normal coin, right, it can be first coin showing head, then tail. It can be also tail for the first coin, head for the second coin, then tail for the third coin again, and also we might have DTH. So again, to simplify this result, right, we are having 3 sets of result in this outcome, therefore I have to multiply with 3. Okay, and after that, what kind of outcome I still have to obtain 2 heads here? Very likely, it is also possible that I will have the tail in the buyer's coin, and then in the fair coin, right, I get 2 tail and 2 head and 1 tail. So if you have a look for this result also, basically it means we are having 2 head in total. Okay, so the tail in the buyer's coin is fixed. Okay, we only focus on these 3. Okay, so for HHT, right, the tail might appear in the second normal coin, or the tail maybe appear in the first normal coin. So again, for this outcome, we are having 3 different results here, so I need to also multiply with 3. Okay, so for me, I think this is the only, these are the outcome that we will get the 2 heads here. Okay, so once we already show all the outcome, then we try to put in all the probability. To get the head in the buyer's coin, it will be 0.6. And then I think the remaining you should know already, 0.5 for all the fair coins. So I'm having 0.5 power 3, then multiply with 3. Same thing happen for this one. Obtain a tail in the buyer's coin should be 0.4, then the remaining fair coin will be all 0.5 and then power 3. And you multiply with 3 also. From here, the answer that you get for x equals to 2 should be 0.375. Alright, then don't forget to fill it inside. So I'm having 0.375 for x equals to 2, and also the probability 0.275 in x equals to 3. If you want to make sure that your calculation probability is correct, you can try to check the answer by sum up all the probability here. If you sum all the probability here and you get equals to 1, then very likely your answer is correct. But if let's say when you sum out all the answer, you didn't get the total equals to 1, definitely something wrong in your answer. Okay, so you can have a small checking up on your answer by using this method. Okay, so we completed the probability distribution table for the x, and let us proceed to next part. So for the next part, they are saying that the expected value is 2.1, and they want us to find the value of variance x. Okay, so just recall the formula need to be used here. To get the variance x is in the discrete random variable, the general formula will be ex squared minus the mean square, the expected value square. So how to get the expected value for x squared? Generally, it is actually the summation of x squared multiply with the probability. Okay, so you square the x and then you multiply with the respective probability and sum them up to get the ex squared. Okay, so we need the table on top actually. Okay, so I want to calculate the ex squared. So just to show you, Okay, so we are having the table here, right? So the first x is 0. 0 square is a 0, multiply with this one, also 0. So we can start from here. I will square the 1, multiply with 0.225. I square the 2, multiply with the probability. I square the 3, and so on. Okay, then I add all the value together. So if I write it out properly in the step, basically it will look something like this, where I start from x equals to 1. So 1 square multiply with the probability 0.225. 2 square multiply with the probability, I get 0.375. Then 3 square 0.275. 4 square 0.075. Okay, so if we didn't do any careless mistake, right, by right we should get the value 5.4 for the expected value of x squared. Right, and please take note this is not the final answer yet. Okay, so please take note this is not the final answer because it is just an expected value for x squared. So we can continue to calculate the variance x. So to get the variance x, the formula is shown here. Expected value of x squared minus the mean square. Expected value of x squared, we get 5.4 minus the mean square. The mean is given in the question, which is 2.1, and we square it. Simplify the answer, we should get 0.99. Okay, so this is how we calculate the value for variance x. Okay, so now we come to question number 3. 80% of the residents of Kinwawa are in favor of leisure center being built in the town. 20 residents are chosen at random and asked in turn whether they are in favor of the leisure center. They want us to find the probability that more than 17 of the residents are in favor of the leisure center. Okay, so for this question, right, we are having 20 residents, which is 20 is a larger number, and then in the question you can see that more than 17 out of the 20 residents, something happened. So this kind of structure belongs to binomial distribution. Alright, so we have to learn how to identify the binomial distribution question. Alright, and generally it will show this kind of structure. Right? Okay, so we will start. Since we know that it is binomial distributed, so let us write out all the parameters for binomial first. Okay, so the first value is the n, which is 20. And then the p here is actually given in the question, which is 80%. So I will want to change it, become the proportion. It will become 0.8. Okay, for the probability part, they want us to calculate the number of residents more than 17. So it should be greater than 17, no equal sign. Okay, so in this discrete random variable, x more than 17 means that I want to include the calculation of the probability for x equals to 18, x equals to 19, and also x equals to 20. So the maximum number for x will be 20 here. Alright. Okay, so for x equals to 18, it will be 20 c 18, and then p power 18, and then q power 2. Then for x equals to 19, and also x equals to 20. Okay, so this is the binomial distribution formula when you want to calculate the probability, and we try to add all of them together, we will get a long list of value. And we try to correct it to 3 significant figure where the answer should be 0.206. Okay, let's have a look for part B. For part B, they want us to find the probability that the fifth person asked is the first person who is not in favor of the leisure center. Okay, so for this question, basically it's like this. When we are trying to ask the person, right, fifth person is not in favor. So that means the first person is in favor, second person also in favor, third one also in favor, fourth also in favor. The fifth person is the first one who is not in favor. So if I want to write out the sequence, it might look something like this. Or you can treat this question as a geometric distribution question, where the keyword here is the first person. Okay, when you see first person shown is on a certain sequence, right? Then generally it belongs to geometric distribution. Okay, so if you know how to use geometric distribution, then by using common sense also you can find out the answer. So this is by using common sense where I try to list out. That means the first four person asked, they are all in favor. Only the fifth person is the first person who are not in favor. So to calculate the probability for this case, okay, first person in favor will be 0.8, right? Second person in favor also 0.8, third person 0.8, fourth person 0.8, and the fifth person is not in favor, so it's 0.2. Of course, you can simplify your answer become 0.8 power 4 and then 0.2, and this pattern looks very, is actually the same like what we had in geometric distribution. Okay, so when we simplify this answer, by right we should have 0.08192. And if I correct it to three significant figure, then I will have 0.0819. Okay, so this is how we answer part B. And let us proceed to part C. For part C, they are saying that the seventh person is the second person who is not in favor of the leisure center. Okay, so when they are saying that the seventh person is the second person who is not in favor, right? Okay, so for this question, we cannot use geometric distribution anymore because geometric distribution is mainly for the first person or first thing, okay, not in favor to occur in general in the general question setting. But for this question, because we are having second person who is not in favor, so we have to maybe use some common sense to answer it. Alright, when they say seventh person is the second person who is not in favor, right? So that means the last person who the seventh person, this is the seventh person, must be not in favor. It must be that this is the second one. And then for the first six person here, I have 5 in favor but 1 not in favor. Okay, so 1, 2, 3, 4, 5, 6. So the first six person must have 5 in favor, 1 not in favor, so that the 7 not in favor. So total, it is the second person who is not in favor. Okay, so when the 7th person must be not in favor, right? Okay, so like what I tell you just now, the first 6 person here, first 6 person here must have 5 in favor, 1 not in favor. But the not in favor one not necessarily must be always the 6th person. It can be actually first person already not in favor, then the remaining 5 is in favor. It can be also first 2 are in favor, the third one not in favor, and then the remaining in favor also. So all the cases here, right, it still belongs to the 7th person is the second person who is not in favor. We need to consider the arrangement for the first 6 person. Okay, you can try to list out if you want, but in general, right, we are having 5 in favor and 1 not in favor. The arrangement can be quite simple, where you are having the not in favor become the 4th person or 5th person. The not in favor can be in the 3rd person. Okay, the not in favor can be in the 2nd and 1st person. So if you try to arrange the arrangement here, basically you are having 6 results. Okay, so that means what? That means the not in favor one can be the 6th, can be the 5th, can be the 4th, can be the 3rd, can be the 2nd, can be the 1st person. Alright, okay, so we have to consider arrangement here. Therefore, to calculate the probability for this case, we need to multiply the 6 later. Alright, okay, so let us start the calculation for the probability once we roughly know the setting, okay? Right, so let's start. So from all the probability here, we are having how many person in favor? So in favor, I'm having 1, 2, 3, 4, 5. 5 person in favor. That means in favor one will be 0.8 power 5. Okay, then for this 6th one is actually the not in favor, so I'm having 0.2. Alright, and like what I mentioned earlier, we need to consider the arrangement for the first 6 person here, and they're having 6 different arrangement. Therefore, I need to multiply them with 6. And lastly, don't forget about the probability for the 7th person who is not in favor. So it is also 0.2. Okay, so if we try to write out the steps like this, then simplify it, we will get the answer 0.0786432, or we will get the simplify the answer into 0.0786, correct to 3 significant figures. Okay, so this is how we get the answer for this question. Alright, so some students, they might want to simplify their step. What they are doing is they will straight away write. Okay, I'm having 5% in favor and then 2% not in favor. And they straight away multiply with 6 by considering the arrangement for the first 6%. Alright, so this is how we answer question number 3. Okay, so question number 4. The probability that it will rain on any day, on any given day, is x. If it is raining, then the probability that Aaron wear a hat is 0.8. If it is not raining, then the probability that he wear a hat is 0.3. Whether it is raining or not, if Aaron wears a hat, then he wears scarf, probability is 0.4. Okay, so if he does not wear a hat, then the probability that he wear a scarf is 0.1. So the probability on the randomly chosen day it is not raining, not wearing a hat or a scarf is 0.36, and they want us to find the value of x. Okay, so by right? Okay, for this question, it is a sequence. Okay, a sequence of events happen. Alright, so it will be quite suitable if we use the tree diagram to show the result. Right, but since the question here only focus on not raining, not wearing hat, and also not wearing scarf, so maybe when we try to write or draw the tree diagram to help us, right, we don't need to draw the whole tree diagram. We can only focus on the result that we want. Okay, so we know that raining probability is x, therefore the not raining probability will be 1 minus x. Okay, so if it is not raining, then wearing a hat probability is 0.3, right? Not raining, so the probability that he wearing a hat is 0.3. This is not raining one. Therefore, not wearing a hat is 0.7. Okay, then after that, if he's not wearing a hat, then the probability that he wearing a scarf is 0.1. So not wearing hat, I will separate again, become scarf and no scarf. Not wearing hat, the probability wearing a scarf is 0.1. So not wearing scarf will be 0.9. So you can see that I only draw a certain part of the tree diagram because of the question only focus on not raining, not wearing scarf, and not wearing hat. Okay, so this pathway generally will be the line, follow this line. No raining, not wearing hat, and no scarf. And they are telling us that the whole line here, the probability is 0.36. Okay, so that means I'm having 1 minus x multiply with 0.7 multiply with 0.9, and we'll get the answer which is equals to 0.36. Okay, so we let it equals to 0.36, and then from here, if you try to simplify the value, you should get 1 minus x equals to 4 over 7, and then you can get the x which is equals to 3 over 7. So this is how we get the answer for this question. Alright, if you want to complete the whole tree diagram, it will be very large. So if you want to save time, maybe you can try to consider by only focusing on not raining, not wearing hat or scarf outcome here. Right, so this is how we answer question number 4. Okay, so let's start question number 5. Marco has 4 boxes are labeled KLMN. So the 4 boxes here will be different because they are having different label. Right, so 4 different label boxes, KLMN. He placed them in a straight line in order KLMN with the K on the left. So Marco also has 4 colored marbles. So I'm having 4 different color marble, red, green, white, and also yellow. He placed a single marble in each box at random. Events A and B are defined as follow. Okay, so before we have a look for the event A and B, right? For this question, if you try to observe, we are going to arrange 4 different color marbles into 4 different label boxes. So for this question, it is actually the questions that involve arrangement, because you're trying to arrange, all right, different color marble into different boxes. So later when you try to solve this question, right, you should try to think about the permutation because it involves the arrangement. Right? Okay, so let's have a look for the definition for event A and also B. Okay, so for event A, they are saying that the white marble in either box L or box M. And then the event B is the red marble is to the left of both green or yellow marble. So these are the definition for the two events here. For this question, they want us to determine whether or not the events A and B are independent. Okay, so let's try to recall back the independent case first. When the events are independent, that means the probability of A multiplied with B equals to the probability of A intersect B. If we are having this result, then A and B are independent. And usually when we want to show whether are they independent or not, we need to calculate the probability separately. So that means you have to calculate the probability on the left, which is A multiplied with B. And also you need to try to calculate the probability for A intersect with B. And after that, we compare the value. If the value is equal, then they are independent. If the value are not equal, then that means they are not independent. Okay, so let's come back to the question here. If we have a look, we are having the 4 boxes here. So maybe I put it like this. So I'm having 4 box. I'm having K, L, and then M and N. Okay, so let us talk about event A first. So for the event A, right, the white marble is in either box L or box M. So that means my white color must be here, or another case is my white color marble must be in the box M, L or M. So this is the first case for event A. This is the second case for the event A, right? The white can be in L or the white can be in M. To calculate the probability for this event A, okay, so like what I mentioned earlier, this is about the question about arrangement. So we have to consider the permutation question. Okay, so for first case, if I fix the white color here, I fix the white color in the box L, right? So definitely I can, by right, I can arrange the other color freely. When I want to arrange the other color freely, okay, you can either think in this way where for the first box, I can have I still have 3 color available, 3 color marble available. So this one will be 3. The box M, this one, there are still have 2 different color marbles available. Then it is 2, then this is 1. So it will be 3, 2, 1. Or you can try to consider it in the way that I still have 3 different color of marble to be arranged in the 3 different boxes. So it can be 3 factorial or 3p3. Okay, so it depends on how you interpret the question. So for you can write either 3 times 2 times 1, or you can write as 3 factorial because I need to arrange the remaining 3 different color of marbles into the 3 different boxes. So it can be 3p3. 3p3 also can be written as 3 factorial. So this is the number of way for case number 1 in event A. Alright, so 3 factorial, but we are interested in probability, right? So we have to divide it by the denominator, where the denominator is the number of arrangement without restrictions. So without restriction means that I want to arrange 4 different color marbles into 4 different boxes. It can be 4p4, or you can write as 4 factorial. So this is the probability for case number 1 in event A. Then how about for case number 2? So for case number 2, also the same. I fix the white color in the box M, and I want to arrange the remaining 3 different color marbles into 3 different boxes here. So it will be 3 factorial as well. Then divided by the total arrangement without restriction. So it will be 4 factorial. Okay, so some of you might want to write 3 factorial divided by 4 factorial times 2 also can, no problem. So if we try to add the probability together, the probability for event A should be half, 1 over 2. Okay, so this is how we calculate the probability for event A. And now we are interested in the probability for event B. So let's have a look what is the definition for event B here. So for event B, they are saying that red marble is to the left of the both green and also yellow marble. Red is to the left. Okay, so when we are saying that red is to the left of the both green and yellow marble, what are the possible cases that we will have? Okay, so now we consider the event for probability for event B. Okay, so for event B, right, if let's say I fix my red color here, then definitely no matter how I arrange the other remaining color, right, the green and also yellow will be on the right of the red marble. Okay, because the question they define it as red is to the left of both green and yellow. So that means if I put red color at the left, the first box on the left hand side, so no matter how we arrange all the other marbles on the right or on the remaining box, the red is always on the left of green and yellow. Okay, so this is the first case. Second case is if I try to fix the red color here, all right, in the box L, okay, and then I have to ensure that the K box is having white. If the K box is white color, the red marble is if the white marble is in the K box and then the red is in the L box, therefore the remaining green and also yellow can be in either MN. So for this result, it is still referring to red is still on the left for green and yellow. So I think these are the possible two cases only lah. Because if I try to fix the red color in the box of M, right, there's no more two empty boxes on the right. So you cannot ensure that the green and yellow are both on the right of the red. Alright, so these are the two possible results for me to have in event B. Okay, so let us consider the calculation for event B, the probability for event B. Okay, so first case, I fix the R in the box of K. Therefore, I can put in any color of the marbles in any box of L, M, N. So I want to arrange them, arrange three different color in three different boxes. So I'm having the probability of 3 factorial, then divide it by 4 factorial. So the number of arrangement without restriction is 4 factorial. So first case done. For the second case, I fix the R here, red color box here. I also fix the white color here. So the only thing to consider for the arrangement will be the green and also yellow, right? So to arrange two different color of marbles into the box M and N, okay, it will be 2p2 or 2 factorial. So for me, I'm writing out as 2 factorial. Then divided by what? Divided by 4 factorial, the total number without restriction. Okay, so if I have 3 factorial divided by 4 plus 2 factorial divided by 4 factorial, so simplify the answer, I will have 1 over 3. Okay, so this is a probability for the event B. Okay, and now let us proceed to the right hand side of the equation where I want to find out the probability for A intersect B. To calculate the probability for A intersect B, they are saying that white marble is either in box L or box M, and then the red marble is to the left of both the green marble and also the yellow marble. Okay, so maybe for this one, I try to use. Okay, now I'm trying to list out the possible result for A intersect B. Okay, so what are the possible results for A intersect B here? Okay, so just now, right, since we are saying that green and yellow is on the right to the marble, red marble. The red marble is to the left of both green and yellow, right? So that means if my red is here, then the remaining 3 will be freely arranged in L and M. But if let's say I want to have the intersection for A and B of the event A and B, this is the event B, right? If I want to make the setting where fulfill the A, so the white can be in L. So let's say white is here. So this is one of the results where the event A and B intersect each other, right? So I'm having red on the right, okay, then white is in the L, then green and yellow is either in M and N, then it fulfill the event A intersect B. Another possible result is if I fix R here and then my W is here, the white color is in the box M, green and yellow, it is still on the right hand side of the red marble. It is still fulfill the event A intersect B. Okay, and then what else do I have? So just now, do I have the third case? For the third case is what? For the third case is I'm having my red color here, green and yellow in either one of these, and then my white color here. But if I fix my red color like this, okay, this is not belongs to event A because event A is saying that it must be white color must be in either L or M. That means we are having only two cases to be considered, okay, in the event of A intersect with B. Okay, so how can I calculate the probability for this one? So we are going to arrange the marbles, right? Okay, so A intersect B. So for A intersect B, first case, case number 1, I fix the red color here, I fix the white color here. The only thing that I want to consider for the arrangement is green and also yellow. When I want to arrange the green and also yellow, right, you can exchange your position, or you are trying to arrange two different color of marble into two different box. So it will be 2p2 or 2 factorial. So I will write out as 2 factorial divided by 4 factorial. Then how about for the second case? Second case also the same. I'm having either green and yellow here, and they can exchange their position. So the concept is arranging two different color of marble into two different box as well. So it should be 2p2 also. Or you can write as 2 factorial again, then divided by 4 factorial. Okay, so from here, if you try to simplify the answer, right, you will have 1 over 6. Okay, so this is the probability for us to get the event A intersect with B. Alright, then let us try to verify and see whether are they independent or not. So I want to get the value for A intersect with, I want to get the probability for A multiplied with B and compare it with A intersect with B. Okay, so I will continue the calculation here. I am interested to find out the probability A multiplied with probability B. So it will be 1 over 2 multiplied with 1 over 3, where it is equals to 1 over 6. So from here, if you try to compare these two values, they are the same, right? So what you can do is that you can make a simple conclusion in this case. So A intersect with B is, A multiplied with B is equals to A intersect with B, and therefore events A and B are independent. Okay, so when the values are the same, basically they will be independent case events. If let's say the value are not the same, then they are not independent. So for our example here, or our question here, these two values are the same actually, so they are independent in total. Okay, then for the method that I show here, right, in this question, I'm using mainly the permutation calculation. If let's say you are not so familiar with the permutation calculation, you can also try to list out all the possible outcomes. So when you want to list out all the possible outcomes, that means the steps might be slightly longer because you need to list out everything. Okay, so as an example, if let's say for event A, right, the white marble is in either box L or box M. So for event A, right, your white color must be in M. White color must be here, either L or M. So if you want, you can try to list out everything, like, oh, I'm having green here, yellow here, then red here, and then you try to arrange all the possible arrangement. Alright, but the step will be quite long if you want to list out one by one. So to me, I think the easiest way will be still using the permutation method, trying to arrange the different marbles into different box, which is permutation concept. Right, so that's why you can see that our step here involve the factorial or maybe the NPR. Okay, so this is the suggestion how we answer question number 5. Okay, so question number 6. In a cyclic event, the time taken to complete a course are modeled by a normal distribution. So please highlight the keyword normal distribution. Okay, the mean is given 62.3 and also the standard deviation is 8.4. They want to find the probability that one chosen cyclist has a time less than 74 minutes. Okay, so the keyword here is normal distribution, right? So please write out the parameter for random variable x. So x will denote the time taken to complete a course. So x is normally distributed with the mean 62.3 and also the standard deviation is 8.4. So parameter I should write it out in variance. So it will be 8.4 squared. And they want us to calculate the probability for x smaller than 74, less than, so smaller than 74. Since we know that this is normally distributed, therefore we have to standardize it become z first. So how to standardize it? You use the value of x minus the mean. So minus the mean means minus 62.3 divided by the standard deviation. So I divide it by 8.4. 8.4 is the standard deviation, right? Okay, get the value for z correct to 3 decimal places. So I'm having 1.393. And we can directly get the probability, okay, from the normal distribution table for 1.393. So looking for 1.3, 1.39 is this one, and then 3 means that you have to add 5 at the last digit of 9177. Okay, so if you try to add 5 to the last digit, it will be 0.9182. You can write your answer correct to 3 significant figure and it will be 0.918. So this is how we answer this question, part A. Right, then we continue to part number B. For part number B, now they are saying that find the probability that 4 randomly chosen cyclists have time between 54 until 50 until 74. We are having 4 cyclists now and all of them are having this time. Okay, so no matter how, we will try to focus on one cyclist first. For one cyclist, the probability of getting the time between 50 and also 74 will be something like this. But this is for one cyclist. Okay, so again, since we know that x is normally distributed, therefore we have to standardize it. So I take the value for x minus the mean, so minus 62.3 divided by standard deviation 8.4. Right, then smaller than z. Then again, for the 74, right, I already get a value in first part A just now, which is 1.393 after I standardize it. Okay, then I will have the value correct to 3 decimal places, negative 1.464. Okay, so to calculate the probability for this particular question, there are many ways that you can solve it. Right by right, this is the area that we want to find out. Okay, so this is basically the area that we need to find out. And then there are many ways that you can take 1 minus the 2 area at the sides, no problem. Or you can just do it like me. I will take the area z smaller than 1.393. So when I write z smaller than 1.393 means that this whole area here, the green color one, and then I will minus the area on the left hand side, which is z smaller than negative 1.464. Okay, so that means I'm trying to minus the light blue color area here, then I get the shaded area that I want. Okay, so for z smaller than 1.393, this answer, I already get it from the part A just now, which is 0.9182. Minus, to get the area of z smaller than negative 1.464, this area, if you reflect it right hand side, it will be a small area as well. So to get the value, I need to take 1 minus. Alright, so no matter how, I will just focus on the value for 1.464 first. Right, so for 1.464, if you try to get it from the normal distribution table, 1.464. Let me enlarge it. Okay, so 1.46, it will be this one. Then 4. So that means you have to add the 6, okay, at the last digit of 9279. add the 6 to the last digit. Then from here you will get 1 minus 0.9285. Okay, so because the area that we get from the normal distribution table, it is smaller than the positive value, right? So we now interested for z greater than 1.464. So I have to take 1 minus. Okay, so simplify the answer here, you will have 0.8467. But again, because this is not the final answer yet, so I will not simplify it yet. So the 6487 is actually for the probability for one cyclist. Okay, where the time is from 50 until 74. And now we are having 4 cyclists in total. So to get the probability for 4 cyclists, we need to multiply all the probability. That means for the first cyclist, I'm having 0.8467. The second cyclist also I'm having 8467, so I have to multiply them. Then the third one also the same. The fourth one also the same. So when you're having 4 cyclists, to calculate the probability, you have to multiply them so that it is a complete case for 4 cyclists, right? So if you multiply them, or you can take 8467 power 4, then you'll get a long value here. And of course, you can simplify it into 3 significant figures for the final answer. So our final answer should be 0.514. Okay, so this is how we answer part B. And now let us proceed to part number C. Okay, so for part C, we are having a different cycling event. The time also modeled by normal distribution. So highlight the word normal distribution again. They are saying that 23% of the cyclists have time less than 36 minutes, and also 10% of the cyclists having the time greater than 54 minutes. So from the information given, they want us to estimate the mean and also standard deviation for this distribution. Right, so for this question, we still know that it is still belongs to normal distribution. The keyword is here, but I actually don't know the population mean and also the variance. Alright, but using the information given here, we can try to find out the mean and standard deviation. So first question is this one, the first information, 23% of the cyclists have time less than 33 minutes. If I try to write out the equation, it might look something like this, where the probability of the time less than 36 will be equals to 0.23. 23% is the percentage or the probability. So I change it become probability become 0.23. So this is the first information that I can write out. And then for 36, right? It is the value of z. So I have to standardize it become, value of x. So I have to standardize it become z. So 36 minus the mean, I don't know what is the mean, divided by standard deviation. I also don't know what is the standard deviation. And it is equals to 0.23. For this equation, if you try to visualize it using a normal graph, okay, 0.23 is a small value, and you are having z less than, therefore you can expect that the value of z is the negative value, where this area is 0.23. Okay, and this is the z value, right? A value of z lah. So for this value of z, it should be negative. How I know it is negative? Because the mean of the normal distribution is 0. Okay, a standardized normal distribution is 0, and the z value is on this side. Okay, on the left hand side of 0. Therefore, it should be a negative value. If I want to find out the z value from the table, right, by referring to 0.23, you won't get an answer because the probability provided in the table start from 0.5 until 0.9986. But I'm having the probability of 0.23. So to find out the correct value, you can take 1 minus 0.23, where you will get 0.77. So that means I'm referring to the area of 0.77 for the value of z. Okay, so this is one way, one method, okay, by using the graph, okay, to find out the value of z. Some students, they might want to use a general formula like moving the sign here and there by changing the sign positive and negative and so on to calculate the value also can, to find the value also can. So for me, I'm mainly using the diagram. So since 0.23 is a small area, it is not provided in the formula booklet, so I will take 1 minus 0.23 to get 0.77. So that means in my probability here, I'm looking for 0.77 for the probability sign. So again, the probability appear inside the table, okay, inside the table here, and then the value of Z appear outside the table. So the 0.77 is a probability, therefore I will refer the value inside here. Looking for 0.77, right, I will try to look for the value that is closer to 0.77 but smaller than it. Therefore, if I'm trying to look for this value, you can see that 0.77, the closest value will be 0.7673. And then I need to add 27, right? I need to add 27 so that I can get 0.77. So if I add 27 at the last two digit, this is what we have, 27 exactly. So to read the value of Z, you go to outside, so you are having 0.739. Okay, so we should have 0.739 for the area of 0.77. Okay, so we come back to our solution here. I know that the Z value should be 0.739, but since from the diagram that we draw here, Z should be a negative value, right? So we will have 36 minus the mean divided by the standard deviation equals to negative 0.739. Okay, how I know it's negative? Because from the diagram here, I can see that my Z is on the left-hand side of the 0, which should be a negative value. So once I have equate the standardized value equals to negative 0.739, you can rephrase it so that you can solve the simultaneous equation later. So I'm having 36 plus 0.739 sigma. And this is the first equation that I have. Okay, then now I continue with the second information. So the second information is 10% of the cyclists have time greater than 54. So if I try to convert this into a symbol form, basically it will look something like this. The time that we have more than 54 is equals to 10%. So 10% is 0.10. Again, if you try to standardize it, you will have Z greater than 54 minus the mean. So minus mean, I don't know what is the mean, divided by standard deviation, I also don't know what is the standard deviation, and then I let it equals to 0.10. Again, if you try to visualize it using a normal distribution graph, Z greater than, and the area is 0.1, which is small value, that means that my Z is somewhere this side, the area should be on the right, and this is the Z. So Z will be a positive value. This area is 0.1. Okay, and again, to get the value of Z from the normal distribution table, right, they won't give you the area which is 0.1. They will give you a value from 0.5 until 0.99 something. So to find out the a line or maybe the tally area for 0.1, right, what you need to do is you take 1 minus 0.10, then you get 0.90. Okay, so when you get the 0.90, that means when you want to read the value from a table, right, you are looking at 0.90. Okay, so you can look for 0.90 from the area here, the probability inside, or you can use a shortcut because 0.90 is a special value. It's quite nice. You can straight away read the value for 0.90 from the critical value for normal distribution table. Okay, so can you see the area here, 0.90, this is the probability, and the value of Z is given 1.282. Okay, so we are taking 1.282 in our solution here. Okay, so for this value of Z, from the diagram, you know that it is a positive value. Therefore, I will get this standardized value Z equals to 1.282. It is a positive value. From the diagram, you can see that it is in positive side. Then again, if you rephrase the equation, you'll get the second equation here. Alright, so since you have first equation and second equation already, so can you please try to solve it simultaneously? Alright, so I won't show the detailed steps here. So please solve it simultaneously. And by right, you should get the value of sigma first. For me, I get the sigma first. Alright, so if I get the sigma value, it will be 8.91, correct to 3 significant figure. And after that, please use the long value of sigma. This is a shortcut value, right? You already cut short the value. If you want to get the most accurate answer, please keep the long original value for sigma, substitute it into equation number 2 or equation number 1 to get the mu. So if you follow the step correctly, right, the mu value that you get correct to 3 significant figures should be 42.6. Alright, so this is how basically we solve question number 6. Okay, so now we are at the very last question already. Okay, they want to find the number of different arrangements. So please highlight the keyword arrangement. It is about permutation. So later your steps will involve all the NPR and also the factorial. Right, we are having 9 letters here and the word is delivered. They want us to calculate the number of arrangement now where the 3 E's are together and the D's are not next to each other. Okay, so first of all, I would like to list out all the letters I have first. Okay, so for the word deliver, right, I'm having 2D, then I have 3 E's, 1 L, 1 I, 1 V, and also 1 R. This is the letters that I have lah. Okay, and according to the restriction given here, right, they want us to have all the E's together. So when you want to have some items all together, right, or cannot be separated, we need to bundle them and treat it as one unit. So I bundle all the E together and make it become one unit only. So I treat it as one letter lah, in general. So that when I arrange them, they are always tied together. They are not going to separate with each other. Then when we are having the case or restriction where the D's must be separated or not next to each other, usually for this kind of question, we'll arrange the letter at last. So that means for now, I'm not going to include the D in the arrangement first. So I want to arrange the 3-letter E, which treated as one unit. Then I want to arrange the letter L, I, V, R. So first step, I try to arrange the 5 letters here first. 5, 1, 2, 3, 4, 5, right? So to arrange the 5 letters here, I'm having 5 factorial. When you look at these 5 letters, this one is one letter only now, one unit. So if you try to have a look for all the 5 letters here, there are no identical letters, right? Okay, that means there's no repeated letters or identical letters because this 3E, although it looks identical, but we already assume it as one unit only. So it is not identical. I mean, they are not belongs to different identical. They are only one unit. So I'm having 5 factorial here. After that, I need to put in the D. Okay, so for D, I'm having 2 D's here. So for the 2 D's, I want to put it into the space between all the letters. So I'm having 1 space available, 2nd space, 3rd, 4th, 5th, and also 6th. I'm having 6 space available for 2 D's. So to arrange 2D inside the 6 spaces, I will have 6P2. Okay, 6P2, but the 2 letters D are identical. So for any identical letters, I need to divide it by 2 factorial. 2 identical, so 2 factorial, 2 identical D. So if I simplify this answer, I'm having 1,800. Okay, so this is how we answer question number 7A. And let's proceed to 7B. For 7B, they want us to find the probability that, okay, so we are focused on probability. The chosen arrangement for the 9 letters in the word delivered has exactly 4 letters between the 2 D's. Okay, so again, we try to arrange the 9 letters. Okay, so out of the arrangement for the 9 letters, right, there has exactly 4 letters between the 2 D's. So again, keyword is still about the arrangement. So we are still doing the permutation now, but we need to include the probability. So for the probability, right, the denominator, we need to have the arrangement without restrictions. Without restrictions. If I want to arrange the letters without restrictions, right, I'm having 2D. So I repeat again, 2D, 3E, 1L, 1I, 1V, and 1R. There are 9 letters in total, right? Without restriction, so I have 9 factorial. So out of the 9 letters here, you can see that I'm having 2 identical E, so I have to divide it by 2 factorial. So I'm having 9 factorial divided by 2 factorial, and also I'm having 3 identical E, therefore I have to divide it by 3 factorial. So this is the total number of arrangement without restriction. Answer should be 30240. And now I want to consider the number of permutation with restrictions. So what is the restriction here? They are saying that we have exactly 4 letters between the two Ds. Okay, so if let's say I want to have 4 letters between two Ds, I have this one, D, and then in between I have 4 letters, 1, 2, 3, 4. Then this is a D again. And in total I'm having 9 letters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm still having 3 more letters at the back. Okay, so for this case, if I want to fix the D, I have to fix the D so that between the two Ds I have 4 letters, alright? So I'm not going to touch the D anymore. That means when I want to calculate the arrangement, right, I'm not going to consider the D anymore because it is fixed there. I didn't arrange them, I fixed them at a certain position here to ensure that I have 4 letters between the two Ds, okay? And now, when I fix the D here, I will want to arrange the remaining 7 letters, right? There are 4 letters here, and there are 3 more letters here. I can arrange the letter freely, okay? I'm having 7 letters, 3E, 1L, 1I, 1V, 1R, and I want to arrange them freely in this step. Basically, it will be 7 factorial. 7 letters, right? So 7 letters, if I want to arrange them freely, it will be 7 factorial. But from these 7 letters, you can see that we have actually 3 identical E. So we have to divide it by what? Divided by it by 3 factorial. Okay, so this is the arrangement for the 7 letters remaining. Okay, when my D is at first position and also the 5th position. Then for this case, you can see also when D is in the first and the 5th position, right? We are having exactly 4 letters between the two Ds. But you can see also, if let's say we try to consider, is there any other possible cases where we are having the 4 letters between two D? It can also happen where I have the D at the 2nd position and also the 6th position. Okay, so when the D is at the 2nd position and the 6th position also, I'm having 4 letters between the two D, and I am also going to freely arrange the 7 letters. So to freely arrange the 7 letters, I have another set of answer where 7 factorial divided by 3 factorial as well. Okay, and if you try to consider for more cases, right, my D can be also in the 3rd position and also the 8th position, 3, 4, 5, 6, 7, 8. And you are having the D with 4 letters in between. And lastly, you can also have your D in the 4th position and the last position, where it is still considered as the case where D is having 4 letters between them. So for all the 4 cases here, all the arrangement will be 7 factorial divided by 3 factorial, like what I showed you in the first case just now. So you can either add all of them together, or you can straight away multiply them with 4. So the 4 here basically means that you're having 4 different cases for the position of D. Okay, and that's why you can simplify the answer for this part. You will have 3360. Then since the question is asking for probability, therefore for probability I need to take 3360 divided by the total arrangement without restriction, which is 30240. And then from this part, you have the answer, which is 1/9 after you simplify it. Okay, so this is how we answer question 7b. Okay, and let's proceed to the part C. Okay, so for part C, now they want to select 5 letters. 5 letters are selected, highlight the keyword selected. This is basically a keyword that tells us about the combination question. So 5 letters are selected from the 9 letters in the word delivered. Okay, so again, I will rewrite again all the letters that I have before I try to select them. Okay, so when we want to select the letter, right, this question does not involve permutation, does not involve probability lah. It is just the number of different selection, number of combination. Okay, and we are having the 5 letters include at least one D and also at least one E. When we are having the identical letter, just like D and E in the combination, right? We actually have to list out the case, all the possible cases, and find out the answer case by case. Okay, right. So the restriction for this question is I have at least one D and at least one E. So the very first case I might have is one D with one E. Okay, in total I'm having 2D and 3E. Right, so the first case that fulfill the probability, the restriction will be 1D and 1E lah. So if I have 1D and also 1E, then the remaining 3 letters, I need to select it from I, L, V, R. Okay, so for this case, the 3 remaining case will be, the 3 remaining letter will be selected from I, L, V, R. There are 4 letters in total here. So the number of permutation will be 4C3. Okay, so I'm not going to consider the selection for D and E because all the D and E are identical. So no matter which selection I choose, they are still D and E. Right, so I'm not going to consider the combination for D and E, but only consider the selection for the other letters, which is not identical. Right, so this is the first case where it fulfills the restriction, at least one D and at least one E. So I might also have the case where I have one D with two E. If I have one D with two E, then I have one D and then two E in the selection. Therefore, I still have 2 empty letters to be selected. So the 2 empty letters, right, can be selected from the 4 letters also, which is 4C2. Okay, and then 1D with 3E. So my result will be D and then E, E, E. Then I have only 1 letters to be selected only. So I'm having 4C1. Okay, so this is the cases with 1D and 1, 2, 3, E. Then now I have to proceed to the case with 2D. So maybe I'm having also 2D with 1E. 2D with 1E, I'm having the case like this. 2D, then 1E. 2 empty letters to be selected, so it will be 4C2. I can have 2D, 2E, where it will look something like this. I have only 1 empty letters to be selected, so 4C1. And then I can also have 2D, 3Es, right? So for 2D, 3E, basically, it already occupied all the 5 letters, the space. So I have only one kind of selection here. That means this is only one result. Okay, then we try to simplify all the answer here. Okay, so 4C3 should be a 4. 4C2 should be a 6. 4C1 is a 4 also. 4C2 is a 6. 4C1 is 4. Then this is 1. And we try to total up the number of combination for all the cases. So by right, you should have 25. Okay, so here we already completed the discussion for all the questions in this paper. Alright, thank you very much for watching this video.